Hi and welcome back. Hope you had a good week. Today we're going to be looking at stage 4 of the product life cycle of a garment, which is the wet processing stage, or the application of colour to either a fibre, fabric or a garment. Pretty important stage because it's the stage that informs the aesthetic to some degree. So uh, we know that we're attracted to colour, we know that we're attracted to particular colours. So as far as fashion is concerned, not only the style and design of the garment, but also the color of the garment is going to attract a consumer to this product. So we ask ourselves, what is the cost for color? And if we look at our product life cycle and ask ourselves, remember we have to ask ourselves two questions: what impact it has on the environment, the natural ecosystems, and what impact does it have on people's lives as well. So I thought I'd start by introducing you to Tyrian Purple, which is a colour that was worn by the Roman Emperor 2000 years ago, as you can see in this depiction in the film Gladiator of the Emperor. And basically it was worn by the Emperor and the Emperor's guards. So it was an exclusive and elite group in the Roman society that wore this colour, simply because it was expensive. And it was expensive because, as the slide suggests, it was made, or you needed 10,000 sea snails, those little ones there in the bottom left-hand corner, to make one robe. So exclusivity created value, if you like, or cost, or price, and therefore only the richest people in a society could wear that colour. You saw the same in the Renaissance with the colour red, that was only worn by the most prominent people in that society, predominantly businessmen and also the church. And also in Chinese society, the colour yellow was often used. Again, all rare colours. Today, exclusivity is contrived, so we can produce any colour at a relatively low cost. So the idea of having a unique colour or a particular colour doesn't come with cost. It just comes through, if you like, marketing and promotion, as you can see by that Dolce & Gabbana dress there, which is not $16.40, it's $16,400 for that garment. So obviously it doesn't have $16,400 worth of imports, but there's a contrived value that Dolce & Gabbana are cleverly able to do with their garments to make them seem valuable to consumers. So I just wanted you to keep that in mind as we go through some of the problems associated with colour, just so we can ask the question, do we really need colour? In the sizing process, so you would have done this in materials last year, but sizing is a protective process where the sizing agents are applied to the yarn to give it strength and to improve the performance of the overall yarn and obviously the garment. So we simply apply starch to it. And you can get starch from something as simple as a potato, although the industry don't use potatoes anymore to size their yarns. They use more modified products, and that's where it becomes problematic, because if you're using a modified starch, particularly if it's genetically modified, well, you're introducing a new entity into the ecosystem. If you recall, last week we looked at GM products, and one of the arguments against GM products, or one of the questions over GM products, is what do they do once they're released into the natural world? How do they react or break down, if indeed they do break down at all? Also, a significant amount of water is used in creating the starch in the first place. And as we know, we have a scarcity of fresh water in certain parts of the world. The other form that starch takes is through PVAs, polyvinyl acrylics, polyvinyl alcohol, which is basically plastic. And again, that requires some water mixed in with it. And it's in the release of that, which I'll talk about on the next slide, which can impact on biodiversity or biosphere integrity, because it can contaminate the water flows in there. So Chen, Reddy and Yang is three researchers who are looking at replacing genetically modified starches with a soy protein. Soy is a plentiful um, crop, certainly used in our food supplies, also used to feed animals. So that's one solution. They're looking at alternatives to that. So some work has been done in that field, although there are some limitations compared to the PVAs. I mean, PVAs are used simply because they're really good at doing their job. Efficiency, but not good at the disposal end of it. Once the sizing or the starch has been applied to the yarn, it has to be washed off or desized. Um, and you simply do that by applying a chemical, and that's where your problems occur. The chemical is an acid, basic acid, sometimes it's caustic soda, um, or some other particular acid, and the excess gets washed into the ecosystem. Once again, if it's genetically modified or if that GM starch is washed away with the acid, you can have contamination of the waterways. So that would need to be treated first, and obviously that comes at a cost. Water soluble desizing simply needs a lot of water. So it's a cleaner process, but needs a lot of water, and it's usually warm or hot water. So you need to consume electricity to generate hot water to desize the yarn. And there we've got problems with climate change and fresh water use. Um, Noman Al Haq was looking at more efficient ways of desizing. So if you're interested in this sort of field, have a look at that paper. Um, and again, there's a significant amount of work in here, but there's also a lot of debate as to whether we should try to improve the existing process or we should look at totally new processes to replace the old ones. The next stage is the scouring of it, depending on what the fibre is. So obviously with wool you would use this, but it's washing, another term for washing, and washing requires water. In this case, it requires caustic soda, chelating agents, which are basically and suffocants, which are basically soaps, to clean it away. And just like when you wash your face or wash your hands, obviously the soap and the excess goes away, but doesn't go away. It goes into the ecosystem at some point, and the natural world has to process that. So it impacts on biogeochemical flows by changing the phosphorus and nitrogen levels, biosphere integrity by influencing the health of the wildlife in the ecosystem, and once again, the need for hot water in that process. So hard to avoid the washing process, but if it's a human-made fibre, there's perhaps a lot less of that process that occurs compared to natural fibres like wool. So some of the solutions for this, if we look at H&M's report from 2015, it's a few years ago, but 6.1 is they ensure appropriate wastewater treatment for all supply factories with wet processes. So H&M has gone through and done an audit on all their suppliers and have basically said, we want to know what you do with your water after you've scoured um, the fibres. And we're seeing that as a growing sort of benchmark in a number of different companies. Excuse me. And again, just another paper there that suggests different um, chemicals that can be used, more environmentally friendly chemicals that can be used in that process. The next stage is to bleach the fibre, so we've basically got to make it white. And the idea is by making it white, you can then apply a dye which is consistent across the entire batch. If you don't bleach it, you can still apply a dye, but you're going to get slight variations in colour across batches. And as you know, with mass production, we want consistency of quality. So we want consistent quality when it comes to the colour. But again, that can be questioned. I mean, would it be so dramatic if there were slight gradations or different shades in colour across within a range? Would the customer see that as sort of something wrong with the garment, or is that just a perception? And can we challenge that perception of customers and consider doing it just in a slightly different way? But the way you bleach it or make it white is chlorine, and chlorine is definitely not good for the environment. Impacts by geochemical flows, fresh water, and again the application of hot water, so generation, the demand for electricity can be problematic depending on the source. I just want to remind you, I keep going on about electricity. If the source is renewable, then it's not a problem to generate hot water in that way. But if it's not, then it becomes a bit problematic. So one of the solutions, Fox Fibre, you may be familiar with this. Sally Fox has spent a lot of time developing naturally coloured cotton, and so normally cotton grows white, but what she's done is being able to interbreed or crossbreed various wild crops to come up with a natural cotton. And the advantage of this is, if I can find it, it doesn't have to be coloured. No, it doesn't need dye at all. You simply pick it off the plant, um, spin it as we saw last week, comb card, spin it, and then present it in the form of a garment. So the nice thing with this is you get unique colours. Every garment to some degree is slightly different and slightly unique. Now, this, for some designers, this is an absolute nightmare because they don't have control of the colour. For other designers, they would find that quite exhilarating. So again, it probably appeals to a particular aesthetic. So a particular a target market would like or appreciate this, but others may not. But that's one way in which you can eliminate the need for dyes. Just simply grow naturally coloured cotton. It's been around for a while. It's sort of up and down in its application. That's largely because of consistency of supply. Because you remember, when you're dealing with this, you can't get consistent supply, you can't get consistent colour, and so it becomes slightly problematic. But have a look at that at some stage if you're interested in naturally coloured cotton as a solution. Uh, the mercerization stage is where you want to get those deep, rich colours in your garment. So you've got to swell or expand the fibres, and you do that with caustic soda. And caustic, as the word implies, is caustic. Don't stick your fingers in it. So with caustic soda, the problem obviously is once it's washed away, it goes into the natural ecosystem if it's not treated, and it's going to impact on biosphere integrity. So it'll impact on the wildlife um, that's drinking the water, if you like, and also the chemical composition. So the biogeochemical flows when we looked at nitrogen and phosphorus, and that balance can be affected by this caustic, the release of caustic into the environment. So as opposed to the Fox fibre solution, which was to go back to a natural solution, you've also got the alternative of applying science and technological solutions such as Green by DuPont, which is just a process. You can have a look at this in more detail if you want. It's just new enzymes they've created that are more require less water, don't require as much caustic soda, and don't do as much damage in the environment. So it's just another direction you could go in with that one. If the fabric is to have a print applied to it, the problems with prints are pretty significant. Problems with the dyes they use, or the inks they use, I should say. Toluene, glycol, and methyl ethyl ketone, pretty negative. I've given you the extreme example. So I mean, this can present itself as melodramatic, if you like. So this is if the person applying the ink is exposed to it over a long period of time, it can have pretty significant health effects for them as well. So it doesn't mean we shouldn't print, it just means we should ensure that the worker is well protected and well educated when it comes to the impact of inhaling the vapors from these products. Okay, we're finally ready for the stage of the application of the colour, or the dyeing stage. And I'll just quote you this part here. During the dyeing process, an average t-shirt would use 16 to 20 litres of water 80% of the dye is retained by the fabric, and the rest, meaning 20%, is flushed out. The global textile industry discharges 40 to 50,000 tons of dye into the water system, and Europe discharges 20,000 tons of salt. Probably less well known is that you need salt as well as the dye itself for it to sink in. So it's a significant amount of both. Those figures vary depending on where what source you get and what measures are used, but it is well accepted that to dye a garment requires an enormous amount of water, and there is a significant amount of runoff or excess that needs to be, what tends to be washed away in the ecosystem. A dramatic example of that is if we look at this Made in China article, where is it, which I'll just bring up there, the Pearl River in Guangzhou, where we can see the release. This is quite a few years ago now. The Chinese authorities have sort of put in more stringent anti-pollution legislation, so this doesn't occur. But this was sort of perhaps 15 years ago, 10, 15 years ago, and you can see there the excess dye running out into the Pearl River. When factories at the end of the day would just release it into the river. No different to Melbourne when along the Yarra River up until the 1960s, perhaps, there was a lot of factories located along the river, around Richmond and such, and they would just dump all of their garbage into the river. That's what you did. As a nation industrialised, the river was seen as an efficient way to dump any garbage you have. And in this case, we can see the dye. I think there's another image up here of another waterway somewhere in China that has dye in there. So pretty obvious problems with that. So what I've got here on the right is just a list of some of the synthetics at different stages, so you can have a full list that you can perhaps research if you're interested in this topic for your final assessment. You might want to focus in on one aspect of this and just report or detail how you could improve that one aspect. If we look at some of the agents, sorry, gone a bit too far. Concerned with the lack of absorption and reflection of sunlight entering the water, leading to algal bloom. So once you've got the dye in the water, the sunshine can't get through that layer of sludge, and that's going to affect the health of that water supply. Many dyes and their components are carcinogenic. They give you cancer, can give you cancer, kidney, bladder, and liver cancer is often found in dye workers who don't wear any protective clothing, and that impacts health, jobs and income in the social economy. And dyes can cause allergies, dermatitis, respiratory disease, etc., particularly azo dyes, which you'll look at in the tutorial. And once again, health, jobs and impact. So dyes are great for colour. They're not great for the environment and for people if they're applied and released into the environment in the wrong way. And that's where we have a problem. We need colour. So socially and environmentally, one of the most damaging stages in the life of a garment, and yet one of the most influential stages in terms of product differentiation. The colours you choose, the patterns that you choose, might be the difference between a customer wanting to buy your product and not wanting to buy your product. So how can we ignore colour? How can we not use colour? But then how do we do so in a way which doesn't cause all the problems I've just mentioned? So in effect, we could describe this as a wicked problem. There are no easy solutions, but we sort of start working towards solutions by making changes or questioning what we do and asking ourselves, is there a better way to do it? So we'll have a look at some examples of that now.